we've been talking about trinomials, right? With 3 factors. All of these are different because they have a b of 0. So this b term is not in any of those other things, right? There's a pattern here. So if I have a perfect square for the first term and a perfect square for the second term, it's really easy to find my 4 terms that go inside those parentheses. And I'm going to zoom in for a minute. See if I can make this look a little better. All right. So this term right here, if it is non-existent, it doesn't exist down here, I can take the square root of the first thing and the square root of the second thing, as long as they're perfect squares. So what's the square root of 4x squared? I'm going to take it one step at a time. Square root of 4 is 2, and the square root of x squared is x. So I put a 2x and a 2x at the beginning of my parentheses. Then you go to the second thing, and you do the square root of 9. What's the square root of 9?
3.
3. So 3 goes at the end, and 3 goes at the end. Because there is a subtraction sign right here, and it only works when there's a subtraction sign, we can do a plus and a minus. That's our factored form. We don't have to do all of these 6 steps that took us so long yesterday. Okay, so if you have 2 terms instead of 3, and if they're perfect squares, and if there's a subtraction in the middle, so all 3 of those things have to work, then you can just take the square root of the first term, square root of the second term, stick them together with 1 plus and 1 minus. So what would that look like for this second one? What would I put in my parentheses?
N.
Mm-hmm. And? 8. And then a plus in one parenthesis and a minus in the other. Is this third example going to work, or is there a problem there? Is it 2 perfect squares with a subtraction sign in the middle? Is it the difference of perfect squares?
No.
It is not. It is the sum. This does not work with the sum. It only works with differences. So I can't do this one. It doesn't work with the sum. It only works with differences. Okay. What about the last one? What do I do for that last example? What goes in my parentheses?
Wait, so the answer is different?
The answer is you can't do it. We can do it not factorable. It has to be the difference, not factorable. Let me make that more clear. Okay? Because it has to be the difference of squares. It has to be a subtraction sign in there. So what if I factor x squared minus 100? What goes in my parentheses? Absolutely. X plus 10 and x minus 10. Okay. So for these examples, it only works if they're perfect squares, and it only works if it is a subtraction sign. Okay. So those are called special cases. So let's practice them real fast. Number 1, what do I end up with? Mm-hmm. What about number 2? Mm-hmm.
2 minus 5
Absolutely. So I've heard from Ashley. I've heard from Mariah. Who else can I hear from for number 3? Don't be shy. Take the square root of the first term, square root of the second term, and then you add them in one parenthesis and subtract them in the other. What's the square root of 9? 3. Nice, Sterling. And the square root of x squared? X. Square root of 4? You got it. So 3x plus 2 and 3x minus 2. Now I've heard from Sterling. So I've heard from Ashley, heard from Sterling, heard from Mariah.
Well, it's my time to shine.
All right, Elias, shine away.
All right.
You're all good.
So, I'm gonna say,
No, you can't give up. What's the square root of 16? Elias, do you agree with Sterling? Is it 4?
Yes, I just said
Excellent. What comes after the 4, Elias?
X.
You got it. And then next? What's the square root? What's the square root of 9?
Oh, 3.
3. Boom. Deuces. All right. What about number 5? Who's going to help me out?
I got you.
Okay, Sterling.
4v
Mm-hmm.
minus 25.
What's the square root of 1?
1.
1. It would be 100% 4v plus 1. Be careful with the ones. People do weird things with ones, and the most common thing is to divide it by 2. You want to take the square root, so just be super careful about that. What about number 6?
2v plus 1.
2v plus 1 and 2v minus 1 in stereo. I love it. Questions on that? This is called difference of squares. That says squares. I know it's impossible to read. My handwriting is atrocious on this computer. Squares. Okay. Difference of squares. If you have 2 perfect squares with a subtraction in the middle, this pattern works every time, and it is so much easier than those 6 steps we were doing yesterday, right? So if we continue down here, you can move this gray box, and it should give you the answers that we just got. Okay. So if you go back to this at a later date, like maybe you go back to this in August, just remember that you can move that gray box to check your work. These are the directions and the video. If what I just did doesn't make any sense, right? You're just going to take the square root of the first number and the square root of the second number with a plus sign and a minus sign. And it doesn't matter which one goes where. We went to the AA6, but it didn't really have examples like this. So I don't know if you're going to want to do that practice or not. The practice was more like what we did yesterday than what this example is. So I don't know that we need to waste time on that. I think we can go ahead and do lesson 4 though. So lesson 4 is going to put together all 3 of these things: the greatest common factor, the factoring using the X factor puzzle, and the difference of squares. So our steps basically are going to be find the greatest common factor and then do what we did yesterday. So if you meet me on slide 26, we're going to do these 6 questions and then we're going to be done for the day.
Miss D, I got a question.
Yeah.
Does it matter if, okay, so this is like, I know it's kind of late to ask, but it just came up in my head.
It's all good.
So, the last 6 questions that we were doing,
Mm-hmm.
this might sound dumb, but does it matter if the plus on the left side?
It does not matter at all. And that's a great question to ask. So here we had the minus at the end, and here we had the minus at the beginning, and here we had it at the end, and here we had it at the end, and here we had it at the end, and here we had it at the beginning. It doesn't matter. More often than not, I put the plus first, but that's just because I prefer pluses to minuses. But whoever answered the question, if they said minus first, then I put the minus first. In fact, I forgot to make a plus on that one. It's all commutative, so multiplication, it doesn't matter the order. You can do 2 times 5 or 5 times 2. Don't matter. That's a great question. So here, these are going to get kind of full, kind of fast. So we're going to do kind of one, and then I'll erase, and then I will do another one, and I'll erase, because it's going to take more room than they gave me space for here. Okay. Step number 1 is going to be to take out the greatest common factor. So what can I divide 2x squared, 2x, and 144 by? What can I divide or take out? 2, absolutely. So I'm going to take out the 2, which means I'm dividing by 2, divide by 2, divide by 2. And what am I left with? X squared minus x minus 72. So the first step was the greatest common factor. The next step is going to be to do your X puzzle.
You write it with the 2 outside.
You do, yeah. It's almost like reverse distribution. So if I was distributing, I'd multiply the 2 by everything and rewrite it. This time it's like a vacuum cleaner sucking the 2 out. So I've got to divide everything by 2 and put the 2 on the outside of the parentheses. It's like you're undoing distributive property. So now I need to do my X puzzle, right? My question is, what multiplies to negative 72 and what adds to negative 1? So I need the factors of 72. For some people, if you're really good with your multiplication facts, this will be easy. For others, you need to do the table. So half of 72 is 36, and then 72 divided by 3 is 24. 72 divided by 4, I think, is something 18. 4 and 18. Doesn't go by 5s. It does go by 6s. So 6 and 12 are getting closer. And then 8 and 9. 8 and 9 are 1 apart. So I know this is going to be 8 and 9. Which one of them is negative? The 9. Okay. Now we're going to put everything back together with our 4 terms. So my first term is going to go first, and my last term is going to go last. And then these are my middle terms. So I need 8x and negative 9x. So plus 8x and plus negative 9x. And Elias, the order doesn't matter here either. If you put the 8 on the left and the 9 on the right, that's fine. If you put the negative 9 on the left and the 8 on the right, that's fine too. It looks like maybe it's going to make a difference, but it's not. So here I want to take out the greatest common factor as well. What can I take out of x squared and 8x? What can I divide both of those by?
1.
Can I divide by an x as well? A 1x?
Yeah.
You're all good. So we want to take out, so we want to multiply by the 2. Don't forget about that. But we're going to take an x out of those parentheses. And once we do the math, we're going to get x plus 8. Right? It gets a little cluttered looking, so make sure you know what the process is. And then what can I divide both negative 9x and 72 by? What can I divide these guys by? Notice that they're both negative. -9. So I want to take out a -9. So I'm going to do -9 on the outside. I've taken that out, right? And I'm left with x. And then -72 divided by -9 is +8. I've got the same thing in both sets of parentheses, so I know I've done it right. And then my greatest common factor the first time was the x, and the greatest common factor in the second set of parentheses was the -9. So those are going to go together. I keep that 2 on the outside, and then I do x minus 9. That's these guys. The x, that's the greatest common factor, and the -9, that's the greatest common factor. They go in one set of parentheses, and then you combine the x plus 8. This is my final factored form. Give you a minute to write that down if you didn't already write it down. And then I'm going to erase it and go over to question number 2. You ready for me to erase it? So again, lots of people, when they're working on algebra, like to take the shortcut and use Mathway, Photomath, whatever. I talk about this every class for like the first month when I'm teaching algebra. Make sure you're investing in yourself. You want to make sure that you know how to do this, right? So step number 1 is always take out the greatest common factor. Is there a greatest common factor that I can take out of 4r squared and 324? What can I divide both of those by? 2 will work. Is there a bigger number I can take out? Try 4, yeah. So 4. If I divide 4r squared by 4, I get r squared. And if I divide 324 by 4, I get, I want to say 16 or 18. What's 324 divided by 4? Oh, it's bigger than that. 81? Yeah, 81. Awesome. What pattern do we have there? Difference of squares. What was the pattern we just did with difference of squares? So I take the square root of r squared and I get r. And then we've got to add 1 and subtract 1, and it doesn't matter which way it goes. And then it is absolutely 9. So what we just did was we took the square root of r squared and got r, and we did the square root of 81 and we got 9. And that's it. I love an easy one. So legit, if you go into business, there's a lot of applications in business that this is like setting you up for. This is like the foundations in order to be able to do higher math. So to do this specifically, probably never. But as a stepping stone to do other things, there are a lot of places that you would have to use this. Yeah, any kind of engineering, you're going to have to be able to manipulate numbers like this. So it just kind of depends on what you want to do. All right, question number 3 is where it gets a little tough. So step number 1 is the same. Greatest common factor. What can I divide 4p squared, 28p, and 40 by? What can I take out and put in the outside of my parentheses? 4, 100%. So if I divide everything by 4, I end up with p squared. 28 divided by 4 is 7p. 40 divided by 4 is 10. Everybody good with that? So then we want to do the X factor. What goes at the top of my X puzzle? The 10, because I factored out the 4. So yeah, we want to do the plus 10. And then what goes at the bottom? The negative 7 for sure. So my question is, what will multiply to 10 and add to negative 7? What are the factors of 10 that will add up to negative 7? Absolutely. I heard negative 5 and negative 2 and negative 2 and negative 5. It doesn't matter which side you put them on. Okay. Then we put everything back together. So I still have to have that 4 on the outside. It's being multiplied. And then I know I'm going to end up with 2 sets of parentheses. My first number goes first, and my last number goes last. And then the middle stuff goes in the middle. And then you've got to find your greatest common factors. So what can I take out of p squared and 2p? P, 100%. So make sure you have that 4 multiply, right? That'll get you if you don't put that multiplication in there sometimes. And then p, and when I divide everything by p, I get p minus 2. Right? So I'm looking for my second set of parentheses to be p minus 2. What can I take out of negative 5p and positive 10? So I'm left with p minus 2. Can I divide by negative 5? And divide by negative 5. And that leaves me with the 2, right? So I'm going to pretend this problem isn't here. Just ignore that for right now. I'm going to bring down my 4. I'm going to collect my greatest common factors in one set of parentheses. So p minus 5. And I'm going to collect my parentheses that match in the other set. And that, my friends, is your final answer. I put my greatest common factor. So I divided this first set of parentheses by p, and I divided the second set of parentheses by negative 5. So I put those together in the first set of parentheses. And then I've got p minus 2 and p minus 2. So that came down here. Any questions on number 3? We ready to go to number 4? We're halfway done. Okay, let's go. I'm going to erase. All right, question number 4. Is there a greatest common factor? That's always where we want to start. There is no greatest common factor. So greatest common factor, check. So now we're going to go to the X factor. What do I put at the top of the X? 16, yes. And I want a negative 16. What goes at the bottom of the X? Negative 2, you got it. What multiplies to negative 16 and adds up to 2? So we can do the factors of 16 if we want. 1 and 16, and 2 and 8. 3 doesn't work, and 4 and 4. Which pair of factors will multiply to negative 16 and add up to negative 2? So if I put in a 2 and an 8, and I make the 8 negative, because the 2 is negative, 2 plus negative 8 is negative 6. So that one doesn't work. You cannot. None. This one is not factorable. You'll have to use the quadratic equation. And we're not learning that today. Okay, so put an asterisk, a star, a something. Eventually in this series of slides, you'll get to the quadratic equation, but that's not our focus for today. Okay, so if the X puzzle doesn't work, and know that sometimes it won't, then you have to go to another layer. Questions on that? All right. Let's go to number 5. Only 2 more to go. It kind of makes me sad. What do I do first for number 5? And what is the greatest common factor? What can I take out of 3n squared, 27, and 54? 3 for sure. And when I divide all of those terms by 3 one at a time, you gotta go to my calculator. What is it? Is it 18? Okay. Second step, factor it. So what do I put in my X to help me out? What multiplies to 18? Because we factored it, right? So what multiplies to 18 and adds up to 9. One of the reasons you want to take out that greatest common factor is because finding the multiples of 18 is a whole lot easier than finding the multiples of 54. Take out that greatest common factor so your numbers are smaller.
Okay. Is it 3 and 6?
It is 3 and 6. And I love equations or expressions that have addition signs. Just makes your life so much easier. Everything's positive. So what do I write in my next line? And it's all going to be plus because 3 times 6 is 18 and 3 plus 6 is 9. So I multiplied to get 18 and I added to get 9. And then what's my last term? 18. Then you got to make sure you take out everything you can take out, right? I've got to regroup. So what can I take out of n squared and 3n? And if I know I want to end up with n plus 3 over here, what do I need to take out of 6n and 18? Absolutely, just 6. And then you rewrite it with your greatest common factors together in one set of parentheses. Don't forget about your 3 hanging out over here. N plus 6. And then you've got your n plus 3 and your n plus 3, so you just collect them. How's our confidence level today? Is it moving up? This 18, we divided by 6, and we divided by 6. So 6n divided by 6 leaves me n, and 18 divided by 6 gives me 3. So it's like that reverse distribution. We took the 6 out, and we took the 6 out, and we put it out here. Last question. Okay. Mariah's off the hook. Somebody else is going to have to pick up the words. What are we doing? Greatest common factor is 5. Once I take out the greatest common factor, I get minus 2x. And then what's 75 divided by 5? Is it 15? And then what's the next step?
X factor.
X factor. And what goes in my X factor, Thomas?
At the top, but -2.
Fantastic. What multiplies to -15 and adds up to -2? 3 and 5. 3 and 5. And if I want a -2, which of those numbers has to be negative?
3.
If the 3 is negative, then I end up with +2. So our bigger number has to match the sign of that bottom number. So we need a -5. We knew it was going to be one or the other, right? What goes first in the parentheses? X squared. Absolutely. What comes next? 3x, I heard. What comes third? -5x. Yep. We got to put those guys in the middle. And then our last term? -15. Look at you. Now we got to take out greatest common factors. So what goes out? What can I divide both x squared and 3x by? X. And I'm left with x plus 3. And then what can I take out over on this side so I still end up with x plus 3?
5.
What kind of 5? -5. Oh my gosh, you're so wicked smart. And then I got to put together my greatest common factors, x minus 5, and put together the things that match, x plus 3. That's it. We're done.